Okay, in this video we are going to see the proof of a Pythagoras theorem. Pythagoras theorem states in any right triangle the square of the hypotenuse is equal to sum of the squares of the other two sides. You see in the diagram here the two blue triangles, both the blue triangles are right triangles here. You can see this is 1.48 centimeter, here also 1.48. This is 3.12, here also 3.12. The hypotenuse is 3.45. Here the hypotenuse 3.45. So where is the square for the smallest side? 1.48. The smallest square is here. This is the square along the smallest side, 1.48 centimeter here. Okay, maybe I can change the color into different color here. It's a green color, right? Then the square of the other side, the 3.12, the square of the other side 3.12 is here. This is the square of the other side 3.12. I will change this color into red color one. Then okay, so now you are able to see the square of 1.48 is here, the square of 3.12, the square built on the side 3.12 is here. The total of these two small squares, must be equal to the bigger one. The bigger one is here. The square on the hypotenuse. The square on the hypotenuse is here. This is the square on the hypotenuse. Okay, maybe I'll change this one into a black color. And okay, so you are able to see that, right? You are able to see this black color here now. So this green and this red, the total must be equal to this square. How you can see that? Now you can see that I'm going to translate the small right triangles here. When I translate the small right triangles, so it exactly matches with the bigger square. So the two squares, the area of the two squares, I cut down the two equal triangles, then I move, it matches with the square on the bigger one. That means the sum of the squares of the smallest sides is equal to the square on the hypotenuse. So what I say, the sum of the areas of the squares on the smallest sides, that is 1.48 centimeter and 3.142, the two small squares. When I cut down the two equal triangles, it exactly matches over the bigger square of the hypotenuse. So what the Pythagoras theorem says here, the square of the hypotenuse is equal to the sum of the squares of the other two sides, provided the triangle is a right triangle. If it is not a right triangle, this is not true. At the same time, if for any triangle, if this statement is true, the square of the longer side, hypotenuse is always longer, the square of the longer side is equal to the sum of the squares of the other two sides, then the triangle must be a right triangle. That is called converse of Pythagoras theorem. Okay, now what is Pythagoras theorem? In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. What is the converse? In any triangle, the square of the longer side is equal to sum of the squares of the other two sides, then the triangle must be a right triangle. Okay.